Good morning. This is Eclipse of the Sun, to tell you about an experience of seeing a total eclipse of the sun, but also to give you some information about what's going to happen when we see from the UK a partial eclipse next Wednesday. So I'll be saying a little bit about eclipses, why they happen and when they happen, telling you about an experience of seeing a total eclipse of the sun back in 2006, amazingly 20 years ago now, it doesn't seem like that. And saying a little bit about future eclipses that will be coming up. Firstly, a matter of safety. Remember, you should never look at the sun unless you've got special eclipse glasses, which are available at the front if anybody hasn't got them. You should always make sure that your eyes are protected. That applies to everybody, regardless of age, and also regardless of species. And some dogs can pull it off with a certain pizzazz and others don't really quite know what they're doing, but it doesn't matter. A reminder that the sun is something like surface temperature of 6,000 Kelvin, which is why it's so bright, which is why it can hurt your eyes. Rather oddly, the outer atmosphere of the sun, called the corona, is much hotter for reasons we don't fully understand, but it looks like the corona of the sun is something like 2 million Kelvin. But it's the surface of the sun, the 6,000 Kelvin surface of the sun, that produces the bright light we see, and that's what can damage your eyes. The Earth's magnetic field protects us from a lot of the radiation from the sun, but some of the particles from the sun get through and cause the aurora. When you go to northern latitudes, you can see spectacular lights in the sky. The aurora came a little further south a little while ago, and we got a little bit of a faint aurora visible in the UK, but it's much more spectacular if you go to northern latitudes. The moon itself, of course, is an interesting object in its own right. If you wanted to observe the moon through binoculars or a small telescope, watching the shadows of the craters or the mountains change from night to night can be fascinating. But here we're not talking about the moon as an object to be viewed. The moon is simply something that gets in the way of the sun. It's effectively a very large occulting disk. So let's see how that works. This is a not to scale image of what's going on. If we imagine that we're on the surface of the Earth, the apparent size of the moon and the apparent size of the sun are very similar. This is just an astronomical accident, as it were. In other words, the shadow of the moon is about 250,000 miles long, and that's roughly the distance to the moon. So the shadow of the moon can just reach the surface of the Earth. If we imagine the distance from the Earth to the moon, if this is the sort of, if you like, average distance, we can get a total of eclipse if we happen to be standing right where the shadow hits the surface of the Earth, and that will be what I call a short eclipse. Because if the Earth were closer to the moon, it doesn't really matter if we talk about the moon being closer to the Earth or the Earth being closer to the moon, but if we imagine that distance was less, then we would be in a larger, more broader area of the moon's shadow, and so the eclipse would last longer because the moon would appear larger in the sky, so it would be easier to cover the sun. And if the Earth is a little bit further away from the moon, then we wouldn't actually be in the moon's shadow, and we would get what we call an annular eclipse. In other words, for a given size of the sun, when we talk about a long eclipse, the size of the moon is rather larger than the size of the sun, and so as the moon moves, it covers the sun for a greater length of time. If the size of the moon is just equal to the size of the sun, then the eclipse is very short, perhaps just a second, and then it's all over. And if we are further away from the moon, an annular eclipse happens when the disk of the moon is smaller than the disk of the sun because the moon is further away. And so if we imagine what that looks like, if we were to speed it up, the moon covers the sun easily in the top case, the moon just covers the sun in the middle case, and in the case where the moon is a long way away, the moon is not large enough in our sky to cover the sun, and hence we get an annular eclipse where we just see, as it were, a ring of fire. Why don't we get an eclipse every month when the moon is between the sun and the Earth? Well, it's because the orbit of the moon is tilted by a few degrees relative to the so-called ecliptic, this plane here, which is the plane of the Earth going around the sun. So because we're tilted by a few degrees, it means that, as here for instance, on the right-hand side, a new moon would cast a shadow which misses the Earth. It's, as it were, above the Earth. On this side, a new moon would miss the Earth because it's now too low. Only when we have a new moon close to this point at which the moon crosses the Earth's orbit, or is in the plane of the Earth's orbit, these points are called nodes, and so the line joining them is called the line of nodes. When that points to the sun, a new moon is precisely on the line from the sun to the Earth rather than above it or below it, and therefore a new moon would produce an eclipse as the shadow then falls on the Earth. So to get an eclipse, not only do we need a new moon, we also need the moon to be at a node. And the question is, how often does that happen? Well, how long does it take for the moon to go from one new moon to the next new moon? That takes approximately 29.5 days. But in the time it takes the moon to go around the Earth has moved somewhat around the sun. And so the length of time it takes for the moon to go from one node back to the same node again is different. That's called the draconic month. And the time it takes to go from one node back to the same node again is not 29.5 days because the Earth is moving around the sun. It's actually 27.2 days. Not only that, but the moon's orbit is an ellipse, and that ellipse slowly changes, slowly precesses around the sun, and the length of time it takes the moon to go from perigee to perigee, the closest approach to the Earth, back to the closest approach to the Earth, because of precession, that's not quite the same. Again, instead of 27.2, it's 27.5 days. So there are three types of month which are all slightly different. And what we're interested in is having a new moon that lines up with a node, and ideally is also occurring at the same time when the moon is at its closest if we want to completely block the sun. Because if we line up when the moon is at its furthest from the Earth, we don't cover the sun. So the question is, if these are the periods of these 3 months, how long is it before they get back into sync? If we start at on a particular day, how long before all of these are back in sync again? Well, somebody has done the maths for us. We don't have to worry about that. But it turns out that 223 synodic months from new moon to new moon happens to be 6,585 and a third of a day. That's not particularly significant, except that a whole number of draconic months, 242 of them, happens to be 6,585 and a third. In other words, there happens to be a coincidence that many integer multiples of that month happen to be very close to that number of integer months of that month. That means if we have an eclipse that occurs on a particular day, then 6,585 days later, the moon will be back in a new moon position and it'll be back on a node again. And therefore, an eclipse will repeat. The perigee to perigee months aren't quite in sync. The best we can do is to say that many anomalistic months, the months of going from closest approach to the Earth back to closest approach. 6,585, not and a third of a day, but half a day. It's different by quite a few hours, and we'll see what difference that makes shortly. But if we concentrate on new moon has to coincide with a node, that should repeat every 6,585 days. This day was known since the Babylonian times, and in a lunar calendar, you can easily work out that this is an important cycle, and it ended up with the name the Saros cycle that talks about when the moon is back in sync with these different months. It means if you have an eclipse on a given day, then 6,585 days later, technically 6,585 and a third of a day later, you will get the same geometry and therefore you'll get another eclipse. So eclipses repeat on this 6,585 day cycle. 6,585 days is just over 18 years. So for the sake of argument, I'll call it an 18-year cycle. So if we imagine total eclipses that have happened in the past few decades, they appear almost at random, not quite, but they will be overlapping Saroses. In other words, the eclipse, the total eclipse of the sun that occurred in the UK in 1999, that geometry of moon occurred again 18 years later, and so the eclipse of 2017 was, as it were, a repeat of the 1999 eclipse. And the eclipse I saw in 2006, again, was repeated 18 years later in 2024. And there'll be lots of these overlapping Saros cycles, each of which repeats every 18 years. What about the fact that going from perigee to perigee, the closest approach to the next closest approach to the Earth, isn't quite in sync with the other 2 months? If we imagine the moon is going around the Earth in a rather exaggerated ellipse, it has a closest approach and more distant approach. The closest approach is called perigee, the more distant distance to the Earth is called apogee. So if we imagine that there's an eclipse, which means the moon is lined up between the sun and the Earth, the moon will be on that orange line there. What happens 18 years later? 18 years later, the moon will be back on that orange line. It'll be new moon again, and it'll be a node, which means it's on the orange line. But the moon's orbit will have precessed slightly. It'll still be elliptical, but it will have moved a little bit round 18 years later. So although the moon will still be on that orange line, it'll be just a little bit closer to the Earth 18 years later. The eclipse will repeat, but the moon will be a different size in the sky. 18 years later, again, the orbit will have changed. The moon will be back on that orange line, but it will be just a little bit closer, or perhaps further away, depending on where we are regarding the precession of the elliptical orbit of the moon. The point being, the moon's distance to Earth will be different each time the Saros repeats. Every 18 years, the moon will be a slightly different distance to Earth. And if I pick out one particular Saros, they're all numbered for the sakes of the mathematicians who want to keep track of which Saros we're talking about. If we take a Saros that occurred in 1988, there was an eclipse in the spring of 1988. The size of the moon compared to the size of the sun, the moon was about 5% bigger than the sun. So it covered the sun easily, and that gave us quite a long eclipse of a little under 4 minutes. And it was visible, generally speaking, from Asia. 18 years later, that eclipse will repeat, but remember, the moon won't be exactly the same distance from the Earth. So in 2006, the one I saw, that distance is different, and now the moon is ever so slightly bigger. It's now a little more than 5% bigger than the sun. Remember, because of the ellipse, the distance from the moon to the sun changes slightly every 18 years. And so the moon is a little bit bigger in the sky, which means the eclipse lasts just a little bit longer. Instead of less than 4 minutes, the eclipse will now last slightly more than 4 minutes. And remember the Saros period, 6585 and a third of a day. If it's a third of a day, that means if an eclipse occurs with the shadow of the moon over a particular part of the Earth, 1 Saros later, because it's a third of a day, the Earth will have rotated 1/3, as well as a whole number of rotations. It will have rotated 1/3 of a rotation. So instead of being visible from Asia, it's going to be visible from somewhere around Africa or Europe. 1 Saros later, the moon is a slightly different size. The eclipse is a slightly different length. The Earth has rotated 1/3 of a rotation because it's 1/3 of a day. And so that eclipse will be seen from somewhere in the Americas. And if we were to then go forward again in 18-year jumps of the Saros, back to Asia again, and then back to Africa, and then back to the Americas, and then back to Asia, we get this repeating eclipses visible in different parts of the Earth every Saros because of the 1/3 of a day that the Saros period is, 6585 days and a third of a day. The distance to the moon is continuously changing, which means the length of the eclipses are continuously changing. That will continue until at some point they'll start to decrease. The distance to the moon will start to increase. The moon will get smaller and the eclipses will get shorter if we were to go beyond 2096, which is of no concern to anybody in the room, except perhaps Rosa, who might actually get to see that one. I said here, eclipses coming soon. You can tell that this is a rather old slide because that actually contains a number of dates that have already gone by. So I was looking at dates from 2020 onwards, a number of different eclipses. These are all different Sarases. But what's important is that apart from the fact we had a few eclipses in the last few years, there is one coming up next week, August the 12th, 2026. It's a total eclipse as seen from some parts of Europe, but unfortunately not the United Kingdom. The moon is a little bit larger than the sun in the sky, about 4% bigger. That gives us an eclipse that lasts about 2 minutes in terms of totality. And if anybody wants to go eclipse chasing, perhaps the next one is really interesting. 2027 in August again. Now the moon is a lot bigger because it's a different Saros. The distance to the moon is rather closer, and therefore the eclipse is lasting a whopping 6.5 minutes or so. And that again is going to be visible from Europe as it's part of a different Saros cycle. We'll see the tracks in just a moment. This is not the tracks for the future. This just happens to be the tracks for the last 25 years. Where has the moon's shadow hit the Earth for various eclipses that occurred? I'm only showing total eclipses in this particular slide. These are total eclipses. Some of the tracks look a bit odd. Bear in mind that the Earth, of course, is spherical, and so when we take the Earth and unwrap it into a map with a Mercator projection, some of these eclipse tracks look like S's rather than simply straight lines across the Earth. And the Earth is rotating as the moon shadow is going across the Earth. So you end up with some rather odd effects in Antarctica and at the North Pole, and most of these other eclipses look like S's. This one in the middle, I'm showing this particular slide because that is the eclipse from 2006, which I'm going to show you just shortly. That's the middle of the eclipse in the Sahara Desert of Africa. If we look forward, I'm now showing total eclipses and annular eclipses. So regardless of how far it is to the moon, whether the moon's capable of covering the sun or not. So total eclipses in blue, annular eclipses in red. And you can see there are quite a few of them. Roughly speaking, very roughly speaking, we might expect to get a total eclipse once every year somewhere on the surface of the Earth. This is the one that's occurring next week. This one at the top, shown in blue, and perhaps you can read it, 2026, August the 12th. So that's the one that's going to miss the UK, but just clip Spain. And there's also one coming up in next year, and that's the blue one, which again clips Spain. Lucky, they get two in a short length of time. Then it goes across Africa and then the Indian Ocean. You might ask yourself, well, if eclipses occur, roughly speaking, once a year, if you take a random point on the Earth's surface, like, I don't know, Liverpool, how often would you expect an eclipse track to actually cross any particular point? And you can answer that by simply saying, well, let's ask for not eclipse tracks for the next 20 years. Let's take a longer period. We could ask for the eclipse tracks for 1,000 years. And it covers most of the Earth's surface. Except there's a little bit of green there. That's Northern Ireland. I think most of England gets covered, but Northern Ireland have not had a total eclipse for 1,000 years by the looks of this. So sometimes you get lucky, and sometimes you get some places that have multiple eclipse tracks crossing, meaning you get multiple eclipse tracks over a period of decades. For instance, the UK has been lucky in the past, but you have to go back quite a long way. So back in the 1700s, there were two eclipses, and you can see them here in 1715 and 1724. So quite a large chunk of England got two eclipses not that many years apart. So people of that era would have seen a couple of solar eclipses in their lifetime. But unfortunately, we haven't been quite so lucky in the last few decades. My friends and I are interested in astronomy, and we thought it's well worth going to see an eclipse which is predicted to come to the UK in 1999 and just clip the very edge of Cornwall. So we decided to book a holiday, went to Cornwall for 1999, and it was cloudy. So we don't talk about that. But having got the idea, because we went there, couldn't see the sun, but it went dark. We thought this is an amazing experience. We definitely want to see what's going on. So we thought there are eclipses coming up. What are we going to do? We decided to go with an eclipse a few years later, 2006, for a number of different reasons. This eclipse track started in the Atlantic, crossed Africa, across the Sahara, across the Med, through Turkey, and then through a few countries that I can't pronounce until it ends up in Asia. We decided to go with that. We didn't mind the idea of traveling. We didn't really want to go halfway around the world, but the idea of going to Africa, well, we could just about manage that. But we wanted to go somewhere where we weren't going to get cloud. So we checked out what is the cloud likely to be on the eclipse track. In March, the UK is likely to be cloudy. Turkey is likely to be cloudy. But lo and behold, it looks like the Sahara Desert is likely to be clear. So we thought, well, if we're going to travel for an eclipse, let's go somewhere where we have a chance of getting clear skies. That is a satellite image of what happened on the morning of the eclipse. You can see most of Africa was clear, no surprise. Bits of Turkey were cloudy, the UK definitely cloudy, and there's the shadow of the moon on its way as it crosses Africa. The shadow of the moon takes a few hours to cross the Earth. It's supersonic, but it still takes a few hours to cross the entire Earth. And this rather nice animation shows you, again, the shadow of the moon crossing Africa and heading off into Europe. It's obviously on a loop to show you the moon shadow crossing Africa over a period of a few hours. There's a blow-up of the eclipse track itself. There's Spain up there, the Mediterranean, and there's the eclipse track going across Libya, Egypt, and then through Turkey. And we're interested in what's going on in this particular part of the Mediterranean. Yes, there's always the chance of cloud in the Mediterranean, but Africa and the Sahara are generally clear. And the eclipse track ran across here. And there was a bunch of astronomers, a bunch of enthusiasts who laid on a ship from Athens, which would then sail to Benghazi and then take you on a coach into the middle of the desert. So we thought, let's go with that. Again, here we are. Here's the North African coast. There's Benghazi. There's the eclipse track. And ideally, you want to be as close to the center line as possible. Anywhere on this track would give you totality, but if you get too close to the edge, the sun is only just covered by the moon, and there's a chance that you would only get a relatively short eclipse. Let's dim most of that down and remind you that's where the eclipse track is. So basically a ship docked at Benghazi, and then very early the next morning, we got on a whole load of coaches and headed off into, well, basically the middle of nowhere on a road. Calling it a road is a bit generous, a track into the middle of the Sahara. And where the track crosses the eclipse track, that's where we wanted to be. But eclipses are easy to predict. So we knew we wanted to be there, but so did everybody else, because that's the one place that you can get to on the eclipse track other than heading off towards the Mediterranean and risking more cloud. So we headed for that red circle, along with thousands and thousands of other people. We're on a cruise ship which had about 800 astronomers. That was a real geek fest in itself. But then when we got to the eclipse site, we found that there were coaches from all over the place descending on this particular point. And there's myself and a couple of friends who are setting up. Of course, we're British, so we take an umbrella with us, not for the rain, but of course just to shade, actually not ourselves, just to shade the equipment. We all took cameras. I took a still camera and a video camera. And I've got a still and a video camera there on this tripod. So we set up, and then I started taking video. Isn't particularly interesting in that video over 2 hours, basically I'm just showing you the stills because it's more interesting. About an hour beforehand, the moon just starts to take a notch out of the sun. Notice that the sun is featureless. There's no sunspots in this particular case because 2006 happened to be solar minimum. I told you about solar maximum a little while ago. The sun is very active at the moment, but back in 2006, the sun was not particularly active, no sunspots visible. But over the period of the next hour, Sorry about the fire alarm. Maybe I'll edit that out of the video later. So over an hour or so, the moon takes about an hour to travel its own diameter. That's a very useful rule of thumb. So the moon started eating the sun bit by bit, minute by minute, minute by minute. It started to cover more and more of the sun. And I must admit, I started getting rather excited at this. Being an astronomer and a scientist, I thought, isn't it amazing that somebody decades ago could calculate that if you stand at this precise point, then at this precise time, the moon is going to precisely cover the sun. The fact that it's possible to do that is amazing. And as I watched it unfold, I thought, wow, I've been waiting for this for about 45 years since I knew that these things existed before I actually got to see them. And as the moon took more and more of the sun, I thought, this is it. Bang on time, we got totality. And we got the famous diamond ring at 10:26 universal time. The last little bit of the sun glinting around the moon's horizon just before the moon fully covers the sun. And perhaps you can see a little pink prominence from the edge of the sun already starting to show. For the next 4 minutes, we simply looked at the sun in awe, either naked eye or with binoculars. It's perfectly safe to use binoculars once the moon has covered the sun. And so we watched and photographed and videoed for the next 4 minutes. If we have a look at the close-up there, we can see all sorts of interesting things going on the edge of the sun. Various little pink prominences were visible, a lot easier to see with binoculars than in this particular photograph. 2 minutes later was mid-eclipse. I'll be showing you some more mid-eclipse photos in just a moment. And then 2 minutes after that, the moon has just started to move away so that the sun is starting to peek around that side of the moon. At this point, of course, it's no longer safe to look at the sun. From this point onwards, we needed to replace the filters if we wanted to watch the sun any further. So it started at 10:26 and it finished at 10:30. This particular eclipse was a 4-minute eclipse. In terms of catching the corona, I wanted to be able to photograph it, and I knew that the corona was very faint, especially towards the outer parts of the corona. But how are you going to get the outer parts without saturating the inner parts? That's a very short exposure, 1/4000th of a second, and it picked up the prominences quite nicely. I also tried longer exposures because I wanted to catch more of the structure of the corona. You can start to see these little furry filaments coming off. These are basically mapping out the magnetic field inside the corona of the sun. But as soon as we go to longer exposures, which allow you to see more detail, I hope you can start to see that, especially at the north and the south end of the sun, where these North Pole and South Pole brushes are visible in the magnetic field, we're obviously starting to overexpose the inner parts of the corona. And if I go to longer exposures still, again, we pick up more of the outer parts, but we overexpose the inner parts. So I took a whole load of exposures, not being absolutely sure which ones would be right. And afterwards, I took all of those exposures and tried to combine them together into one image. The actual exposure, the actual final image, I'm quite happy with, but bear in mind for the live audience, this projector is actually overexposing the inner part of the corona. So I invite you later to have a look at the laptop where you can see more detail that's visible. I decided to try and enhance the contrast to see as much detail in the structure of the corona as possible. Again, I did that and it looked quite nice on the laptop, but unfortunately this projector just completely saturates the image. So again, I'll show you that later on the laptop. When it comes to viewing totality, some people just don't appreciate what it's like to stand in the shadow of the moon. And when people say, does it get dark? Well, yes, it gets dark. And this sequence gives you an idea of what it was like over approximately 1 or 1.5 minutes. You can see that it definitely gets dark. So here, my friends and I are taking images with our cameras, using our binoculars to look at the sun. And we had separately a video camera just a couple of meters away, photographing the experience, just so that we had a short video of what it was like to experience watching the sun. And I warn you that this coming video contains some Americans, and therefore it gets a bit loud at times. This is just going into totality. I'll explain what it is we're looking at on the ground afterwards. We can see the shadow of the moon coming. We can see Venus and other planets in the sky. And it's about to go into Diamond Ring. We're about to lose the sun. Some people are getting rather excited. I'm using a remote to continuously fire the camera. And there we're just going into totality. Some people are using flash in their camera, which is not a good idea. But at this point, it's safe not to use filters, and therefore we've now got binoculars and we're looking at details around the edge of the sun, looking at the prominences and all the other details in the corona. And for the next 3.5 to 4 minutes, the videos continue to run, and I was firing away the camera continuously to catch a whole load of individual images. It was one of those situations where you genuinely use the word awesome. I try not to use that word too often, but watching an eclipse of the sun live is indeed as close to awesome as you can ever get. So visiting Africa, well, there's a lot of reasons why you might want to visit Africa, but far and away, the most exciting thing I've done in Africa is watch that particular total eclipse in 2006. So here in the UK, we're not going to see the total eclipse next week, unless you actually want to go somewhere and leave the United Kingdom. What we have next Wednesday is a total eclipse visible from the middle of the Atlantic. There's the track of the moon's shadow. It misses the United Kingdom. It clips Bilbao and just misses Barcelona by the looks of it, and just clips Spain, and then that's sunset on that side of the eclipse track. So we don't get totality unless you want to take a boat out into the middle of the Atlantic, but we do get 90-something% of the sun covered. From Liverpool, it'll be about 92% of the sun will be covered. And there are apps on your phone that will show you this if you're interested. So this was an app on my iPad, and I just ran it August the 12th from 6 o'clock onwards, and it shows the moon covering the sun and then not quite giving us totality. A different one gives us a little more detail as to the timings. That's what you would expect halfway. So this is approximately 13 minutes past 7 o'clock. The precise timing depends on where you are in the UK. I think this was not necessarily Liverpool. From Scotland, it'll be a few minutes earlier. From the south coast, it'll be a few minutes later. But it's shortly after 7 o'clock in the evening on Wednesday, the 12th of August. A different web page gives you an idea of the timing. It simply shows you where the moon will be at just after 6 o'clock. Remember, it takes about an hour to cover the sun and then about an hour to uncover the sun. So at 6 o'clock, the moon is just starting to clip the sun. That's the partial eclipse starting. and then the eclipse will get deeper and deeper and deeper until mid-eclipse, which is just after 7 o'clock. And then for the next hour, the moon will move away and uncover the sun again. The sun will be in the west. It won't be particularly high in the sky. In mid-eclipse, the direction is 277, which means west, give or take a few degrees, and its altitude is only 10 to 15 degrees above the horizon. For the eclipse in Africa, the sun was very high, so it was really neck-breaking to have all of the cameras pointing up and continually necking backwards in order to get views of the sun. This one will be easier because the sun will be lower in the sky. It'll be easier to see what's going on as long as you have a clear western horizon between 6 and 8 o'clock, preferably somewhere around 7 o'clock BST next week. So I hope the skies are good to you next week and you have some possibility of getting clear skies and a clear horizon for the partial eclipse. But I do urge you to think about putting on your bucket list going somewhere in the world that allows you to see a total eclipse of the sun. Thank you all very much.